Swayam Prabha. Digital India. Educated India.
When we look at the traditional networking elements such as switches and routers and try to see their role of control plane, we see that they serve a variety of goals. Foremost is the routing. Here, they may perform a variety of distributed routing algorithms. For example, it could be link state or distance vector algorithms that we can configure, and the routers would interact and build the routing tables. Second, they provide the mechanisms for traffic isolation by means of configuring the access control lists or setting up of the virtual LAN IDs, or even could provide the firewall functionalities to drop specific set of flows. Third, they would also provide the means for control in terms of traffic engineering and the mechanisms to aid the aspects to do traffic engineering on those devices. By traffic engineering, what I mean is the process of reconfiguring the network in response to the changing traffic loads so that we are able to achieve the desired operational goals. In essence, the traffic engineering would cover all the measures that would be needed to optimize and control the traffic that these specific network elements would process. And this would be able to guide us to have better throughput and desired QoS levels. And as such, traffic engineering is a part of network planning, operations, and management especially from all the ISPs do this. And this would include the mechanisms such as admission control, differentiation of the services, and even building failure resilience. You might have heard about the MPLS, it's multi-protocol label switching. And also you would have learned in your undergrad about how you set the weights for each of the links in order to meet specific aspects of what links need to be considered when you want to route. That's done through the adjusting of the weights. So we can see that the current state of the control plane is quite complex with rich set of mechanisms, but no abstractions as such. Hence, the apt question would be to see if we should apply the abstractions, then what kind of abstractions should we be applying for the control plane? To do this, let us look at the key challenges with respect to the control and management of these network elements. One, we already outlined that there is a lack of abstractions that would enable us to build the right means to interact and facilitate the services. But second, when we look at these abstractions, we also have to think of, why abstractions? In essence, what the abstractions would allow us is to preserve the core essential characteristics of a device and take out the unwanted complexities that we may have to deal when we are trying to configure and manage these specific devices. What this means is, from a network operator's perspective, if we think, what we would need is not how we should be able to update, but understand that we should be able to express our intents in very simple form. Like if I want to configure a specific routing algorithms, I would just express the intent that I want to set link state routing. And once we do that, we also want to control specific aspects of the link state routings to be expressed, like in terms of what weights we want to set in an easier and coherent manner. Nonetheless, what we see in the current model, when you mention the routers, configure the updates on the router, these routing algorithms are often distributed and run on their own. That means the intent, what a user wants for a specific flow to take a specific path, may not be met at all, because these routing algorithms would learn based on the desired weights, and many a times you would have to go back and readjust the weights to see, are we meeting our outcome? And this makes it much more complex to operate with these kind of elements. Further, when you have these multiple routing algorithms like internal and exterior gateway protocols that have to co-interact and enable you to build the necessary forwarding rules, these interactions also in a way affect the way the device would behave in terms of the forwarding plane. Hence, it becomes really unpredictable, and also it becomes difficult to manage the way the devices would be configured properly as we expect with our intention for the device to work. Moreover, there are also the bootstrapping issues that would come up when we want to have the correctness of the data plane reflected by the aspects of how the control plane is set up. And there is also this fragility or the risk of change that would occur when any of the things in the data plane change, or any of the configurations that would impact back on the control plane setup. All in all, what we see is that this control plane management is more or less what is driven completely by what the vendors would provide to us, and has become an impasse in terms of what we can do the innovations here. And this is something that we also need to take into account and ensure that we are able to overcome this to provide the better innovations be done on this control plane. And to do that, we need to look at what exactly are the control planes aspects that we need to be thinking of to provide the right abstractions. And we know that control plane must compute the forwarding state. And to accomplish this task, the control plane would have to figure out what the network looks like. That is, what's the underlying topology, what are the links, and the interacting neighboring devices, and overall the devices that are in the current topology, so that we can come up with the forwarding state. Second, once they would identify the key aspects of how the topology looks like, then they would have to go and run the algorithms that would enable to build the routings in the way that we want the weights to be accounted for, be it the weights in the inverse model to say that okay, the weights correspond to the either the delay, or in a direct proportion to say whether the weights correspond to the bandwidth, and then actually affect the routing intentions that we want to carry out. And eventually, once we have figured out a particular route or a path, then we would also need the mechanism to tell the switches or routers to exactly update the corresponding rule, forwarding rule, which would then make sure that the packets would go and take that particular rule in getting forwarded. So we need right abstractions at all of these layers. And these would be the natural requirements for us in terms of how we want to build the control planes aspects when it comes to managing the forwarding state. And if we have to do this, we need to look at what are the wanted aspects here. And the three that we outlined would be the most desired aspects when we want to set up a forwarding plane. And when we build this, any of the aspects that are unlikely for us to be able to manage could be left out at the device specific properties. So consider this analogy that we would build in programming. And what I mean by this is, suppose you were told to write a program wherein you have some specific part of the program that is hardware dependent, and maybe some of the information that you would want to store is dependent on certain hardware characteristics. And if we are given such a programming problem, a natural thing for us as programmers is to think of the right abstractions that we would want to build, and we would want to modularize our code and try to build the interfaces in such a way that we abstract out the machine dependent characteristics from the machine independent part and handle the machine specific concerns in a separate internal modules. This way, we would be able to reuse the machine independent modules across different machines or different hardwares while we may only have to rebuild the machine-specific characteristics to suit the underlying hardware requirements. And such has been the case when we look at most of the operating systems that we use today, be it the Linux, the Windows, etc. And that's where this abstraction enables much of the reuse and easy to facilitate and suit any kinds of the hardware. And now we can think of applying similar an aspect to the networks as well. And what it means is we need to rethink of the control plane mechanisms that we discussed before and try to come out with the right abstractions which would make them work across multiple devices. In this, if we rethink of the three key characteristics that I outlined, we need to ensure that we have the right abstractions where if we have figured out what the network looks like or what's the topology like, we should be able to reuse this information in providing multiple of the control plane functions, not just to ensure that it is applicable only to set up the rules for forwarding, but it could be used for various other purposes. Second, if we write the set of interfaces which would say how to configure the forwarding state in a very generalized fashion, then this can be adapted to any of the hardwares to suit how the actual configuration of the forwarding would be done. Think of this as an instruction set architecture that we use, like whether it is a RISC or x86 machines that we most commonly use. Once we define the instruction set, these can be adapted and underlying microarchitecture at that time or the computer organization really doesn't matter. That would operate the way the hardware would try to use. But the interface remains fixed. And the same, we can now think of the forwarding state. If we define the right set of state or the interface to configure this forwarding state, we can take it and apply to any of the hardware devices. This way, we can see that we can establish that the topology information could be reused and the way that the forwarding states can be applied as a machine independent characteristics would become very handy to apply it across different routers or switches. And this is all the SDN as a control plane abstractions is all about in terms of trying to build the better model of abstractions to the control plane. So if we think of the SDN control plane, we can think of two specific abstractions that we would want to build here. The first is the global network view. That is, we want to provide the information about the current network. And this, when we think of an implementation, we can term this as the network operating system, wherein it provides exactly the information of the underlying network and abstract out what each element is all about. Allow the user to use the networking elements to set the intention on the networking element without worrying about how and where aspects of the networking elements. And when we think of this network operating system as a rich abstraction, this needs to be run somewhere. And that's we can think of as running on one specific dedicated server, which could be just as a computer PC that we use or the server machines. And for reliability purposes, we may even think of having this server replicated across multiple machines. Or you can think of this network operating system as a distributed platform where a user would see and interact with such a system at one point, but it may be physically replicated at multiple ends. And the second most fundamental abstraction that we would want is the forwarding model, or what we can call as a generalized forwarding model, which would provide a standard way of defining the forwarding state. And such a way of defining a forwarding state is what we learn as the open flow. And once these specifications of the flows are defined, and in this it is open flow paradigm, it is called as a match action pattern, where you define the set of constructs on which you would want to match the data plane packets and pick out the set of headers and try to match the key characteristics from there. And for a given match, you would want to take specific set of actions. And the actions here is basically what to forward or transform the packet, modify the packet headers, or even to drop the packets as well. So in this model of the generalized forwarding with this kind of a specification of match action on the flow entries, note that we are moving away from the destination IP based forwarding that occurs within the routing devices. And this gives us a lot more flexibility and a lot more control over how we would want to forward the packets. So, having established these control plane abstractions and having enhanced our SDN model of the separation beyond the separation of control and data plane, building the right abstractions at the control plane, now we would have to reconsider our earlier question of why we would want to do this.